All right, here's our figure today, a pyramid. Pyramid. Let's start difference between a pyramid and the prisms we did yesterday in cylinder. One base. Everybody, one base. Okay? And that base, I will always tell you, you don't have to assume or ask me. The base of any pyramid we talk about is always regular, which means what to us? Whatever shape it is, it doesn't matter. What do you know about all the sides? They're all congruent. So whatever the base is, all right, for any of the pyramids we discuss, whatever the base is, we assume that the base is regular. All right, all the sides are congruent. Okay, that's why we talk about regular pyramid, regular pyramid, and one base. And what do you know about all the other faces now? They're not rectangles anymore like they were for the prism. What are they? Take the base away. What are all the faces now? What shape are the faces? 12. What are all the shape of our faces that are left? Not here. Oh, sorry. I don't know who you would think I know by May. So I take off that base. All the faces are what shape? Triangles. Always, always. All right. Take off the base. All the remaining faces are triangles. And let's just make a note here. All non-bases are congruent triangles. Okay. Those are all congruent, those triangles, all the time, because it's a regular pyramid. The base is regular, which means all sides are equal, and the remaining triangles are all congruent as well. All right, all the triangles are congruent. So what am I trying to tell you? You find the area of one of the triangles, you know the area of all of them. Okay, all the triangles are congruent. Here's the big part for today, though. A pyramid. Two heights on a pyramid. Two heights. You have what's called the altitude, and you have what's called a slant height. All right, you have what's called a slant height and an altitude. Have you guys ever seen the movie Mission Impossible or are familiar with it? Maybe, maybe not. Yeah. It's like extreme. It's got some extreme stunts and everything in it. Pretty good special effects. That's how I'm going to describe to you the difference between these two heights. All right. So here's where I need you to envision right now. All right. You're in a Mission Impossible scenario right now. And now it's a snack. Okay, we're good. Probably an ad. What do you think? Yep. Probably should have played the ad before I started on. Okay. So here's what I need you to envision here. You are in the pyramid right now. Not just in the pyramid, you're at the top point. All right? You're at the top point, which is called the apex. All right? So you're at the apex right now. And you have to get down. Everyone now envisioning this, yes? You're at the top and you need to go straight down. And all you have is a rope with you. So from that apex, that top vertex, you drop that rope right down, straight down. So it forms a right angle at the bottom. Imagining that rope now, that's the altitude. All right, I'm going to start calling it Mission Impossible height. That is the altitude of your pyramid. All good? You are in the pyramid at the top on the apex. Can't get down. The only way to get down is drop your rope down. And that rope from the top all the way down perpendicular is your altitude. All good? Okay. So what is the, I'm going to keep it going too, by the way, slant height. So we know that, and I wouldn't draw this in because it's going to get sloppy. We just talked about, here you are dropping that rope down. That's your height, altitude. What's the slant height? Remember, what did we say all the faces were? Triangles, right? So on the triangle, you have a height on that triangle. That is the slant height. It's the height on one of the triangular faces. Everyone see the difference? All right? The altitude, boom, straight down. Mission Impossible height. Slant height is the height of one of the faces, the triangular faces. All good? See the difference? Yes, no, we're good. The two heights. Now, there's a special relationship between those two, the Mission Impossible one I just showed and this slant height. They are two sides of a right triangle that we can make. Okay, there will be two sides of a right triangle. So take a look. Slant height, right there. Mission Impossible height, the altitude. And then this right here, every time is going to be half the side of a base. And I'm just showing you, and we're going to work on this. So those two, along with half of the side of the base, forms a right triangle. And guess what we're going to be doing with those? Probably applying what theorem we've used all year long. Pythag, yeah. Pythag. Good. You ready to use it there? Yeah, I'm keeping it going. Lateral area. What'd you learn yesterday about lateral area? I don't have a formula for you. What'd you learn yesterday about lateral area? Everything but the base. Ready? Take off the base, what's left of a pyramid? What's left? A whole bunch of what? Triangles. Everyone know the formula for a triangle? Darn right. Ready? 1/2 BH. And then we're going to multiply that by the number of triangles. All right, I think we're good. Ooh, I have the tiger next. Ooh, that's a tough one. That's a tough one to skip. That is a tough one to skip. Sorry, guys. Can't skip that one. They could get it tapped right now. I might just flip out. All right, so take a look at this first one right here. What's the 8 pointing to? What's the 8 pointing to? Altitude, right? That you're in the apex and you drop that rope down. There's your altitude. 12 is the base length. Ready? Lateral area. Take off that square at the bottom. Ready? Take off that square. How many triangles are left? 4. So it's going to be 4 times 1/2 base times height. Well, good. All right. Help me find the area of one of those triangular faces. 4 times 1/2. You can fill in for B, right? What's the base of one of those faces? 4? 12. Now, whoa. We got to be careful here. I'm not going to plug in 8 here. We're not understanding the heights then. I'm looking for the height on one of the faces, which is also known as, that's my slant height I'm trying to find. And do you guys see the right triangle we've been talking about? You guys see the right triangle in there? All right, help me find that slant height now. All right, this ends up being slant height. All right, how can I find it? Pythagorean theorem. Eight squared plus, ooh, what about that other leg? Remember what we said, it's half the base. So what is that other leg of the right triangle? How long is it going to be? 9? Yes! 6 squared. And now we're looking for the slant height, which is the hypotenuse. Good. When you have it, let me know. 9 again. 10. There it is. There's your lateral area. It's number of triangles times 1/2 BH. What we got there? 240. Any issues there? Go in. Sure. All right, now, what about the surface area? area? What am I putting back on now? The base, right? And how many bases are there? Just one. So now lateral area is just going to be LA, or surface area will be lateral area plus, watch, I'm just going to put big B, capital B. All right. Big B for me. And what's big B? Area of the base. I can't tell you what it's going to be. It might be a square. It might be a pentagon. It might be a triangle. All right, so can we go back to our figure we just had previously that we found the lateral area for? Can you guys help me find the surface area of it now? Same exact pyramid. We just found the lateral area to be 240. Now we're going to add on the area of the base. And I told you guys already the base is always regular, right? You can assume the base is always regular. How do I find the area of this base now? 13 plus 12 times 12. No, I think I'll end it there, even though I'd like to keep going with the hell's bells, but we're good. That'll give me, I won't be able to teach anymore. 144. So we're looking at 384 square feet. So we are right here. I'll try to change it up here a little bit. All right, let's get into it. Numbers are going to be flying from the generator now. Lateral area of this regular pyramid. Lateral area. Take off the base. Here you go. My first question. How many triangles are left? 3. How many triangles? Leave somebody else here. 9. How many triangles? 4 times 1/2 BH. Yep. Now I'm just focused on one of the triangular faces, and that's it. One of the triangular faces. What are the base and height of one of the triangular faces? You're welcome, by the way. You're welcome. 10. What are the base and height of one of those faces? Is that 10? Iris? All right, sorry. Everyone just don't talk all at once. 4. What do you got back there, stud? What's the base and height of one of these faces? 13. It's all there. Remember, it's all, I don't have to, hey, if you guys are thinking you got to find the Mission Impossible height, no. The slant height is what I'm looking for when I find the area of one of the faces. So 10 and 13. Done. $260 square inches. Ooh, how about this one? This one's going to be a tricky one. 4 faces. I won't ask that again, right? 4 faces, 1/2 BH. What's one of the bases? Base length of a face. That's so much rhyming in this unit. Base length of one of the faces. 5? 7. 7. So 7. All right, everyone ready? Hopefully you're not plugging in 7 again because, hey, is this 7 pointing to the height of one of these faces? No, it's pointing to the height of the pyramid, the Mission Impossible height. So I don't want to use that. So I'm going to have to use Pythag. So I'll use 7 squared, which is the height, the Mission Impossible height. What are you going to put in for the other leg now? Take your time. What do we plug in for the other leg measure in that right triangle? It's 8.
7.
Ooh, be careful. This right here, right? What did we say that was?
Oh, it's 3.5.
Half the base, yep. So 3.5 squared. Everyone's seeing that. Always take half the base. And I know this is going to become a decimal that we're not going to round because we're not done with the problem yet. And you're taking the square root of 61.25, right? So So I'm just going to plug that in, 61.25, the square root of that. Just if you plug the decimal in, don't round it. Multiply everything else. What we got? 109.6 square meters. All good. I'm going to let you do one on your own now. All right, find the surface area of this pyramid here to the nearest tenth, even though I think you don't need to round. You shouldn't have to round on this one. Surface area. So lateral area plus the square base. All right, lateral area plus the square base. I always do that. Yes, you have to round to the nearest tenth. God, I always do that on this problem. I use 5 and I shouldn't. It should be 12 squared plus 2.5 squared. So you do have to round.
One half this height times 4 plus the base. Because there's 4 triangles. The set has to be used for area.
147.6. Anything we want to talk about? Right here, brother? Okay, fine. I got you. So we're good? All right. I at least wanted to show you something other than a square base. Okay, other than a square base, and how do I tackle this now? All right, so now we got a hexagonal base, and I want to find the surface area for it. All right, so let's start. Let's find the lateral area, and then we'll talk about capital B here for the area of that hexagon. All right, now how many triangular faces are there here now? 2?
6.
6. So now it's going to be 6 times 1/2 BH, right? Everyone's good? Not 4 anymore. I'm not worried. I'll deal with the base separately, the hexagon. All right, so everyone take a look at one of those triangular faces. I made this one pretty easy because I didn't want to waste time. What is the base and height of one of those triangular faces now? One of those triangular faces. What are the base and the height going to be? What do you got here? 10? Okay. Oh, learn probably not. 13, Charlie, what do you got?
6.
Yeah, 6, and then I tell you the slant height, which we need to use, is 12. So there's the lateral area. Everyone's good with that? All right, you ready for the base now? Now we have to go back to last unit. And we did this last unit. Where's my hexagon? Let me draw this out. We need to find the area of this hexagon. Okay, we did this in last unit, so let's take our time. Remember, we draw in the 2 radii. Let's take this slow. We draw in the 2 radii. And I'm going to try to find the area of that triangle and multiply it by 6 of them. Right? Remember finding that. All right, anybody remember the angle here, or how to find the angle in between before I draw in the height? 360 divided by 6, so that's 60. When you draw in the height, it gets bisected, so now we're working with our 30/60. And also that 6 just got bisected, didn't it? So now there's a 3. So what's the height going to be? Use your 30/60/90 rules. What's the height of this particular triangle going to be? 1, Anna?
3 radical 3.
3 radical 3. Is everyone all right before I start putting some numbers back into the formula? Everyone all right with these numbers? All right, here you go. Let's go back to my surface area. So here was the lateral area. All right, now ready for the hexagon? Everyone ready? How many of these triangles do I have again? 6 times 1/2. Look at it. What's the base of one of those triangles? Remember, I'm talking about this full triangle here now, right? Because I got 6 of them. 6, and we just found the height to be 3 radical 3. That's some high-level stuff right there. But it is going back to last unit, so you have seen it. And now it's taking your darn time on your calculator and typing all that in. Let me know if you want me to go over again where everything came from. This right here is just all the work for B, capital B. The old marching band. Getting after it today. Maybe I should have asked if they could have played the Mission Impossible theme and had them all in here just blasting away. How's 309.5 look? Square meters. How's everyone feeling? All right, you know how we end every class. I warned you yesterday. This is how we end it. Taking figures we already know, mash them together, and what's the total surface area? All right, what's the total surface? Let's mash them together, and what's the surface area? All right, first, tell me what I have here. What are these? What's this figure made up of? This and a this. All right, what's this figure made up of here? All right, Anna, what's this made up of?
A pyramid and a rectangular prism.
Everyone's a prism, pyramid. Let's talk prism first. All right, let's do the prism. Let's do the surface area of the prism. How many faces are all faces? Tell me how many faces total are there? 9. How many total faces do I have? 6? Yes, 6. I don't know why I blanked there, but yes, 6. How many are showing that I could only count for surface area? 5 of them, right? And they all don't, hey, I'm not going to go 5 like I did for the cube on the homework. I won't go 5 times this times this. You need to find the area of all 5 right now and add them together. All right, so here we go. You want to start, Elio? What's 1? How can you find the area of one of them? 6 times 3, right? Are they all 6 times 3? They're all going to be 6 times 3, aren't they? Oh, the bottom one. Relax. So 1, 2, 3, 4 of them will be 6 by 3. You guys should be up here teaching, huh? And then the bottom one, the floor there, will be 6 by 6. So that takes care of all 5. Is everyone all right? Why I'm not counting the top 6 by 6? It's covered up. Surface area. I only count what's there. So the prism should have 108 square feet, I think. Check me on that. 108? Okay. And Anna also said, I also have a pyramid here. Talk to me. What can I only count for the pyramid as a surface area? Because the whole pyramid is not showing. Only some of it. Tell me about the part that is showing. 13, Charlie, what's showing? 4 triangles, also known as? Oh, I got you there. Sorry. The what area? Lateral area, right? Yeah, 4 triangles. You were right. 4 triangles. Basically, I'm doing the lateral area. 4 times 1/2 BH. Yep. And you guys are lucky here, aren't you? Four times 1/2. What's the base and height of one of those faces now? 11. Kelsey, what do you got? 6 and 4. Good. So the area of the pyramid would be 48. And the total surface area, we add those bad boys together. (156 square feet). Questions? Any comments, concerns? Okay. If you want to get your Chromebook or get a book, it's up to you. The textbook pages are on Classroom too. Whew. Good work.